Tom told me to go ahead and get started, so for those of you who don't know me, I'm Bob Udy. I'm the welding coordinator for Salt Lake Community College in Salt Lake City. And get started with, there's conversations goes on within our advisory committee from time to time about teaching aspects of a quality program as used in the industry. And in that, a lot of times they want us to teach more and more about welding codes and about welder qualification, weld certification, and so forth, procedure certification and qualification. So in that discussion, there's been some other discussions between me and a few other people, and I'm going to give my co-author here, Larry, some credit here, because Larry Zerker, as he did a lot of work on this, and he was asked by Idaho State University a while ago to their welding technology instructors to write something about codes. And near the completion of his work, Larry asked me to review what he'd written, and so I went through it and reviewed it and edited it, and he also asked a couple of other CWIs to do likewise, so they've gone over it as well. And we believe that the information is pretty accurate. However, we're always looking to make improvements, and so we welcome any comments or help you might give us, and if you find that we're doing something maybe a little off kilter here a little bit. But so this tutorial was written to be shared with welding instructors, and the intent was to give you some material that help you and your students understand the roles of codes and expand their code knowledge, and to define the relationship between qualification and certification, code welding, and essential variables. Now the goals for this tutorial are first to teach the basic facts on three commonly used welding codes. And sometimes as we go through here, the terms between codes mean the same thing, but they're phrased differently. And the second goal is to present students with ideas about how codes address areas of qualification, and third, to explain what essential and non-essential variables are. Now, it'd be really great if all welders were qualified to the rigor of code requirements and qualifications, but not all shops and jobs require this. And a lot of times the shops that are using welding codes, they pay more money, but they don't but they require a lot more rigor in following a quality program and inspections and so forth. And I'm not going to read through every one of these slides up here. This is part of the tutorial that you can use, and if you want to modify it, whatever, you can do that. So codes were initially written to address safety and develop a consensus with terms and materials and processes. Consider A514 material, for example. When do you inspect it after it's welded? Anybody know? Yeah, and we after 48 hours. And why do we wait? Yeah, delayed cracking. So this is something that would be important for students to understand something about the materials that the codes cover. Okay, these are the three main welding codes that beginning welders will be exposed to, and we've got to get the right slide. There we go. There's a misnomer here because we call them codes, but not technically a code in regards of API 1104. They refer to that as a standard, but we call it a code a lot of times anyway. depending on what's to be welded will determine which code is going to be used. In the introduction of this tutorial, you might ask your students questions like, you know, when would API 1104 standard be used? And they'd have to come up with, you know, where it would be used. Now there's a lot of other codes out there. A lot of us have worked with those codes and seen them, and there's things, you know, in aerospace, there's stainless steel and aluminum codes, there's sheet metal codes, there's railroad and bridge codes, and there's a multitude of military codes, but this tutorial is based on just these three codes. Okay, the D11, the structural code is probably one of the best known of the codes. Its roots began in 1919. D11 has worldwide applications, and if you look at the other AWS codes, there's over 240 codes, guides, and standards that the American Welding Society publishes. The ASME boiler and pressure vessel code is about 5 feet wide, and it covers a range of topics. Section 9 details weld and welder qualification. Section 2, Part C, contains details germane to welding rods, electrodes, and filler metals. Section 5 details non-destructive examination of welds. And this tutorial, again, focuses on welding procedure and welder qualification as we go through. Okay, the API standard 1104 details the welder and weld qualifications for welding of pipelines and petrochemical facilities like pump stations and refineries, etc. There's a kind of an interesting field testing method in API. In the API standard, it uses a nick brake to test weld quality. There's no tensile or bend test when you're out in the field. So it's kind of interesting that they do that. There's some differences between the codes. For example, the AWS D11 allows for pre-qualified weld joints and specific welding processes, except for short circuiting. Pre-qualified procedures can be used by a fabrication shop, and you don't have to qualify the weldment with destructive tests if they are given pre-qualified status. API requires destructive tests on all procedures and welders, and AWS and ASME allow using X-ray in lieu of the destructive test for qualification. So, there can be other differences, but these are just a few of the things that we put in there. All codes and standards have provision for qualifying procedures and specifications. Certifying welders, the employer's excuse me, qualified welding procedures. One of the problems with welding codes and the terms is that they're not all universal. You'll find some different acronyms and different terms used between the codes. Okay, in the AWS code, there's 3 forms used to track qualification. We have the Welding Procedure Specification, or the WPS, excuse me, Welding Procedure Qualification Record, the PQR, and Welder Performance Qualification Record, which is referred to as the WPQ or the WPQR. Here's some information about the WPS and how it's used. Again, I'm not going to go through every one of these. I don't think that's necessary to do that. This is for you to teach to your students. But the WPS, you want to make sure that they know, that the students know that it is supported by the procedure qualification record. And here's the information on the PQR. The PQR basically documents the test results that were used to qualify the welding procedure specification. Welder performance qualification. This is something we talked about a little bit yesterday about the welding performance qualification of welders is to be used by the fabricator or manufacturer. The person that's who certifies the welders. Okay, API code forms. API uses a very simple method to track weld and welder qualification. And the ASME Code, here's some similarities and differences between the, how it differs a little bit between the codes. It has many forms for tracking qualification of the weld and the welder. And these are just some of the differences here. The WPS is the same as AWS. The PQR is the same as AWS. Welder performance qualification, or WPQ, form is a little different. And then they have a demonstration of standard welding procedures, specification of the SWPS. So, welding performance qualification. This is the welding process essential variables. Let's see, I'm on the wrong page here. Okay. These are qualified by mechanical tests or maybe radiography, depending on the code. The fabricator, again, that employs the welder is responsible for their qualification here. Okay, this is the standard welding procedure specification page. And the SWPS, they don't need to be qualified because they're based on successful practices that are documented over the many years and compiled in the archives of the AWS. And these are the ones you can purchase from the American Welding Society. And the SWPS procedures are just for the joint. And in just a few more slides, we'll see an example of a pre-qualified joint. The essential variables need to be developed by the fabricator. WPS documents the WPS documents the company welding procedures in this case. Now we'll look at some examples pulled from actual codes. We're not required to use these exact forms. These are just examples. The format can be as unique as the company that needs them, but all the data displayed in the examples is required to be used in all of the formats. Okay, here's the AWS WPS or PQR. This is the front page. And if you look in the back of the code books, you can find these examples, these samples. And here's the same form, but the back page, the information that's there that needs to be put in there. Okay, this is an example of the AWS welding procedure specification. The front page it's all filled out, so it's an example of what you would see on a standard form. And this is the back page that's filled out. Okay, it's always good to talk about the pre-qualified joints, and here's an example of just showing the joint. And the fabricator has to generate, again, the essential variables to make it their WPS. Okay, this is the API procedure specification form. And it's their version of the AWS and ASME WPS. APIs are a lot more simpler than some of the other codes. And this is the same as the PQR. This is the API form. This is the ASME WPS, and this is the front page. So you can see as we go through the codes, the formats are a little bit different. This is the back page of the ASME form, WPS. The ASME PQR front page. And the back page. And this is the ASME WPQ, or Welder Performance Qualification format. And this is the suggested ASME SWPS format. Okay, now any one of these forms, you can spend a lot of time with your students going through all the specifics of what's in each one of those forms, and you could even make a full class time on some of these forms and talk about what the different variables are and how they affect the weld. Larry produced some really nice flow charts, and we're going to show you some of them here. They show the progression of the WPS from WPS to welder qualification, and it kind of shows the big picture for all three codes. And so, I'd suggest when you get these that you print them out onto 11 by 17, so they're easy to see. You hand them out to the students so they can follow them. But there's some pretty good flow charts. I can't see it as good up here on my computer. It might. Is that coming out blurry? Everybody's okay. Okay, I can't get it to sharpen up any more than that, but and I need a magnifying glass to see it off my paper. Okay, but basically what it does, it takes you through all the steps and of going through to qualify the procedures and qualify, get down to welder qualification. Okay. This is the one for the ASME. Okay, and this is the same type of flow chart for the AWS. That's not focusing very good. Okay, well, this is the flow chart for the API weld and welder qualification steps. But these are really good charts. They print out better than they look up here. So I didn't know what they were going to look like on the projector. Okay, there's three categories of welding variables. The essential variables constitute the main part of the welding parameters which guide the welders or weld operators to make sound and repeatable welds. And so here's a little sheet on the essential variables that you can expand on. Talk about the essential variable details, your base materials, your filler metals, position, preheat, etc. And then we have that second category of non-essential variables. And here's a list of some of those, the brand of welding wire, the welding machine, cable size, things that won't change the quality of the weld necessarily. And your supplementary variables. This is information that items that are needed if you're using impact properties. Okay, then in the AWS code, you can find a list of essential variables, and you'll find it on the chart on table 412 in the D11. In the ASME, the essential variable text here, you'll find that in QW 350. And in the API code, you find the essential variables text here. Now, note that there's some differences between code as you look through these three. You'll find there's some differences there between them. Okay, and in conclusion, we I want to thank you for attending. This tutorial is free for download, and Larry has it on his website, zerkerconsulting.com. And when you get it, you can modify it to whatever's going to fit your needs. But it's a good basis to start with, and you can develop some good lesson plans with it. Okay, and let us know as you go through there if you see something that needs to be fixed or changed. Let Larry know about it.
It takes a little bit to download, so it's not an instant download. It may take you a couple of minutes for it. It's 29 megabytes, so it's a pretty big file.
Okay.